Right, everyone, we are doing Euclidean geometry today, like I've said already. Thank you for joining. I'm very excited to be going live again, finally. So this is question 8. This is from last year's November exam. And they are giving us some information here. Now, before I start reading through the information, it is important to note that in the Euclidean geometry section of the paper, they always start off with nice, easy questions. So the first question here, 8.1 in this case, is really work that we can do quite easily. All right, if you know your theorems, if you know your reasons, you can easily get full marks for this. Last year it was only 6 marks, but that's better than nothing. Oh, there's sounds outside. Okay, so they're saying in the diagram, O is the center of the circle. MNPR, so MNPR is a cyclic quad. That is important. I'm going to highlight that. I'm going to show you guys a way in which I always approach Euclidean geometry questions. I call it the pre-question analysis, but we'll talk about that now. And then they're saying that SN is a diameter of the circle. That is important. Chord MS and radius OR are drawn. So let's see, where's MS? MS is over there, and then radius OR is over there. Now guys, we do actually have more than one radius drawn on this picture. They have just specified radius OR for some reason, but there actually are more radii here. I will show you just now. And then they're telling us that angle M2 is 64, which we can see on the picture. It's important that you read through this carefully because sometimes there is information given here but not on the picture. Now, if you followed me on TikTok for a while, you have probably seen, I'm actually going to just zoom in here so that I have a big white space that I can write on. You might have seen my videos about Dr. Cape Town. Now, I live in Cape Town, so I really like using this abbreviation. This is a way of just remembering, oh, sorry, I bumped into my tripod here. It's a way of remembering things that we need to or that we need to look out for when we are looking at a circle geometry question. So the D is for diameter. So when we have a question, before we start actually looking at what they've asked us to calculate, look for whether you have a diameter on your picture, because we know that when we have a diameter, that can possibly give us a 90-degree angle. So let's quickly take a look here. They told us in the description that SN is a diameter, but we can also see it by looking at the picture because it's going from a point on the circumference to another point and it's going through the center, right? So SN is a diameter. And we know that a diameter always subtends a 90-degree angle. So that means that angle M is going to be 90 degrees. Right, so I'm filling that in. I haven't even read what they're asking me to calculate. Sorry, I'm just seeing this thing is a bit skew. Let me try and fix it. So I'm filling that in immediately just because I know that it's a diameter. All right, there is no other angle subtended by the diameter. There isn't one on this side. So that's all we can do for now. Let's go on to the next letter. R is for radius. So radius or radii, because when we have a radius or multiple radii, we will often have an isosceles triangle, and that can be very useful when we are working with angles. What is diameter's term in Afrikaans? If I'm not mistaken, it's a middle lane of a circle. Van dit gaan deur die middel. Okay, so R is for radius. So let's take a look. They told us that OR is a radius, so I'm going to put that little line there. But now we also know that OS is a radius, so I'm going to put that in there. They haven't actually drawn in this triangle, but if they had drawn a line there, I'm just going to show you guys quickly, right? If that was given, then we could say that those two angles are equal. Okay, I don't think we're going to need it in this question, but that's just an example. And then ON is another radius, all right, that we could also possibly use. So I'm just filling that in. I might not even need to use it, but yeah, we'll see. All right, C is cyclic quad. So we need to check on the picture. Either they have to tell us that it's a cyclic quad, or we can see on the picture that it's a cyclic quad. And what we're going to look for then is that opposite angles equal 180. That's something that we can look at. And we can also look for the exterior angle of a cyclic quad. What is C in Afrikaans? A cyclic quad is a koorde vierhoek. Sorry, I had to think hard about that one. A cyclic quad is a koorde vierhoek. All right. Thank you, Lizzie, for doing the translation. That's very helpful. All right, so they told us that MRPN is a cyclic quad, right? So I'm just going to highlight that. I really like highlighting things on the diagram. I just find that it makes everything so nice and clear, but also sometimes your picture can get very busy, so you need to kind of try and find a balance here. So now what we can see, this is a cyclic quad, and we know that opposite angles of a cyclic quad must add up to 180. So we can already see that M2 is 64, so that means that angle P, we can calculate that. We can say 180 minus 64, and that is going to be 116, if I'm not mistaken. Yes. It's been a long day. I don't always trust myself to do the basic addition and subtraction correctly at this time of day. All right, but we know that angle P is going to be 116. We don't currently actually have an exterior angle here of the cyclic quad. Remember, guys, an exterior angle is always when you have a side. So let's say, for example, if we had PN, any of the sides of the quad, but that side is actually lengthened, right? Then that angle on the outside, that would be an exterior angle. So we don't have that in this case, on this picture. So that's it for the cyclic quad, I believe. Last two letters, P is parallel lines. And guys, it's actually so useful if you identify your parallel lines right at the start, because when you have lines that are parallel, there are so many things that you can do with that. You can work with alternate angles. You can work with corresponding angles. You can work with co-interior angles. Right? Alternate angles and corresponding angles are equal if they lie on parallel lines. Yes, evenwydige lyne, thank you. Co-interior angles equal 180. I'm just going to add that here to my little note. And we could also possibly work with prop theorem. So we'll get to that in the next question. We have to work with that. But prop theorem is also something that we can use when we have parallel lines. So that's also something that's really great for you to recognize at the beginning. Also, guys, there is a thing here about subscribing. Don't even bother with that. It's just kind of there on my live. I didn't put it there. I don't think I did, actually. All right, so something that I also always tell my kids, my classes, is if they've given you parallel lines on a diagram, you are going to have to use them somehow. They will never give you parallel lines for no reason. Okay, so as soon as you see those arrows, you need to know there's going to be something that I need to do with that. In this case, they haven't given us any parallel lines, but that is definitely something to look out for. The last letter, the T, I'm sure you guys can guess what that stands for. That is tangents. Tangent or tangents. So in Afrikaans, that is raaklyne. Now we know that we can use tan-chord theorem. If we have a tangent, that is where the angle between a tangent and a chord is equal to the angle subtended by that chord on the other side of the chord. So I'll show you that later. I'm sure it will come up. We don't actually have any tangents on this picture, so I can't show you guys now, but I will show you if it comes up. And then another thing that we can use for tangents is that we need to remember that a tangent is always perpendicular to a radius. So that is usually a very nice way of getting 90-degree angles in a picture if you have that. All right, so that is something that I really recommend if you are looking at a circle geometry question and you're feeling overwhelmed, you don't know where to start. Think of Dr. Cape Town, look at all of these things and see if you can find them. T is raaklyne. Tangent, a tangent is a raaklyne. All right, so let's get going with this question, guys. Now what you'll see is when you've done your pre-question analysis, which is this Dr. Cape Town thing, we've actually already found the first question that they've asked us, right? The first question that they're asking us for now is to find the size of angle P. We already actually know that angle P is 116 degrees. Where did that come from again? That came from opposite angles of cyclic quad. So all that's left for us to do now is to write that down. Okay, 2 marks. What I do have here is I have the question book, the booklet, just so that I can show you guys what it will look like. I do suggest that if you have access to printing facilities, that you print out 1 or 2 of these answer booklets and you actually work through it so that you can get into the habit of working in this booklet. Your paper 2 will be in one of these, so it's good practice. And also guys, what I've actually done here, it was not the right thing to do. I've done all my like filling in on the question paper. You should actually be doing all of that in your answer booklet so that the marker can see that. So actually I should have done all of these little marks that I've put on here, these symbols that I've put in and the values, I actually should have done that over here. Okay, so that is a very good tip. Do all your writing in the answer booklet, but that's fine. I can just swipe back and forth. So angle P is 116 degrees, and the reason for that is going to be opposite angles of cyclic quad. Now I am sitting at a bit of an awkward angle at the moment, so if my handwriting is not great, then please excuse. So opposite angles of cyclic quad. That is a 2-mark question. They always give you 1 mark for the value and 1 mark for the answer. I mark paper 2. I've marked paper 2 for 7-8 years now, so I can also give you guys tips on how you will get marks. Let me just take a sip of my drink quickly. Thanks for all the follows, guys. I really appreciate it. All right, 8.1.2. M1 is the next thing that we need to find. Now, guys, again, something that I've already filled in here, oh, my apologies, is coming in handy. If I'm looking at what we have there with angle M, we know that M2 is 64, that was given, and angle M1 plus M2 altogether should be 90 degrees because that angle is subtended by this diameter. The reason for that is angle in semicircle. So M1 is going to be 90 minus 64, and that is going to be the answer. Now you need to make sure, guys, that you fully write that down, right? Because the 90 wasn't given, so I do have to write that down. So I'm just quickly going to show you here. In my answer booklet, I'm going to say M1, oops, not in red, let me change that. M1 plus M2 is equal to 90 degrees, and the reason is angle in semicircle. You can also write angle subtended by diameter, but I just find that this is a shorter reason to write, but both reasons are fine. Oh, sorry, it's off the screen. So now I'm going to say which one am I finding? M1. Yes, M1 is equal to 90 minus 64. You don't have to write that calculation down. I am going to, but you don't have to. M1 is 90 minus 64. So M1 therefore is 26 degrees. All right, so now let's put that 26 there. It's a very good thing also that whatever or whichever angles you've calculated to actually fill them in on your picture, because often you need to use, say, the answer to question 2 in your answer to question 3, which is actually what's going to happen here. Apologies for that dog barking in the background. O1 is the next one that they're wanting us to find. O1 is this angle over here. Now, guys, I want you to notice that O1 is at the center and it is subtended by this arc of the circle, arc SR. Now SR, yes, subtends O1 at the center. It also subtends M1 at the circumference. We know, hopefully by now, that an angle at the center, an angle subtended at the center of a circle, is always double the angle subtended at the circumference by that same arc. So M1 is 26. That means that O1 has to be double 26 times 2, so 52 degrees. So do you see what I mean? We had to use our answer to 8.1.2 in order to find the answer to 8.1.3. all right, so O1 is going to be 52 degrees, and the reason is going to be angle at center equals 2 times angle at circumference. All right, so let's write that in. Just want to see that this is on screen. O1 equals 52 degrees, angle at center equals 2 times angle at circumference. You do unfortunately have to write that whole reason down. I know it's a bit of a mission, but there you go. That is what you're going to get your mark for. I forgot to put marks in for the previous one. Let me quickly check. It was 2 marks each. For this one, you would get a mark for the angle in semicircle actually, and then a mark for your reason M1. So guys, you don't really have to write that down as a statement on its own, as long as you have the angle in semicircle, that reason, and then your answer. And then the next one, 52 degrees, that will get you 1 mark. Sorry, that's off screen again. And then angle at center equals 2 times angle at circumference, that will be the second mark. Right, I hope you guys are all fine with that one. I want to move on to the next question, which has to do with prop theorem and midpoint theorem and so on. This was an interesting question. They don't usually test this section without putting the diagram in a circle, so I was actually exams aren't this easy. This is an exam. This is last year's exam that I'm working through. You can see there at the top, DBE November 2022. All right, so as I was saying, it is unusual that they test this without putting the diagram in a circle, but maybe that's where they're going with this section. Maybe they are going to keep testing it like this. I do feel that, yeah, that is probably what they are starting to do now. So let's just quickly go through what they are telling us here. They're saying in the diagram, triangle ABG is drawn. All right, so we have that triangle. D and E are midpoints. D and E are midpoints of AB. AB is over there. And AG, respectively. Oh, thank you for the rose. That's lovely. Now, guys, this is important, right? I don't know if you remember midpoint theorem, which is something that you were supposed to learn in grade 10. But I think some schools possibly skipped it because it didn't used to be tested in detail, but now they tested it last year and they tested it in 2021 as well. So I think midpoint theorem is making its comeback at the moment. I think they really are going to test it probably this year again. It's looking that way. Now, midpoint theorem, I'm just going to write it down so that you can see, and I'm actually going to write it in this little block next to the diagram so that you can see how it works. So midpoint theorem says a line, sorry if my hand is in the way, I'll move it out of the way now. A line joining, and if you've never heard of this, I do suggest that you actually write it down because like I said, I think they are going to test it again this year. A line joining the midpoints of 2 sides of a triangle is parallel to the third side. I also think it goes blurry when my hand is right underneath the camera, but I'll move it away just now. And a line joining the midpoints of 2 sides of a triangle is parallel to the third side and equal to half its length. And when you are using this, the reason that you need to write down is very simple. It is one of the nicest reasons, I think. Midpoint theorem, that is all you need to write down. Yes, midpoint theorem, that's what this is. So yeah, like I said, please do write this down if it doesn't sound familiar, if you've never heard of this before, or if you forgot. Nick, yes, great, that is, you learned this in grade 10, so that's good that you got it right. Hello Ayon, one of my grade 9s. Shonice, maybe. Not this year, unfortunately. There isn't enough time. I am not going live tomorrow. I will be going live on Friday again, and I'm going to be doing functions, I think. All right, let's get back to this one. A line joining the midpoints of two sides of a triangle. So that is actually what we have in this case, right? Because they are telling us, and they're also showing us on the picture, that D is the midpoint of AB, and then E is the midpoint of AG. So DE, right, is a line joining the midpoints of two sides of this triangle. And midpoint theorem then says that because of that, this line will be parallel to the third side. Oh, they've actually already used one arrow on the picture. Let me do a double arrow there. That is what midpoint theorem says. Line joining the midpoints of two sides of a triangle is parallel to the third side and equal to half its length. So what that also means, guys, is that this line, whatever the length of that line is going to be half the length of the third side of the triangle. All right, so they might tell us what this length is, then we need to halve it for that, or they might tell us what this length is, and then we need to double it to get that length. All right, so for 8.2.1, the first thing that they're asking us here, give a reason why DE is parallel to BH. Guys, that is the reason, right? The reason for that is midpoint theorem. So I'm going to write that down. Again, I have the page here. Also, so that you can see, guys, they've given 3 lines and you literally just have to write the words midpoint theorem. So don't be put off by the fact that maybe sometimes they've given you more lines than you have needed. That's fine, right? You're not always going to fill in all the space. Sometimes they give too much space, sometimes they give too little space. It's difficult to predict. All right, so midpoint theorem is the answer there. That's it. I just quickly want to also read through what was given next because I didn't. I stopped there at the midpoints. They're saying AG is over there, and BG, which is over there, are produced to C and H respectively. Guys, the word produced, I think people are often confused by this. This just means that those lines are lengthened. Or extended, I suppose, is a bit, because even now looking at that word, it doesn't actually look like a word. Let's change it to extended. All right, AG and BG are extended to C and H. Basically what they're telling us, guys, is that this whole thing is a straight line. All right, that is a straight line. And then they're also telling us that that whole thing there from B all the way to H is also a straight line. That is what they're telling us when they give us this information. F is a point on BC. F is a point on BC. Yes, we can see that. Such that FG is parallel to CH. Now, guys, this, if we look at the picture that we have here, right, I'm already thinking that we are probably going to have to use prop theorem in this diagram here, in this triangle, because that is something that we can use when we have parallel lines, right? Oh, sorry. Let me just move this a bit. My tripod is quite unstable, so I'm trying to not touch it. All right, so we are probably going to have to use prop theorem. Let's see what the next question is. We already know the answer to the first one. Give a reason why DE is parallel to BH. It's because of midpoint theorem. If it is further given that, and now they're giving us ratios, and now I know people start getting a bit antsy about this. FC over BF, where's FC? FC is over here, over BF is equal to 1 over 4. Now guys, what I do with this, and this is very important, please don't fill in on your picture 1 and 4, right? Because then it looks as if you are saying that FC is 1 unit and BF is 4 units. It's not necessarily, right? That just means that whatever FC is and whatever BF is, what the actual lengths of those sides are, if you write those sides as a fraction, that fraction will be able to be simplified to a quarter. So it might be 2 centimeters and 8 centimeters, right? Because if you put 2 over 8, you will get a quarter. It could be any pair of lengths that will simplify to a ratio of 1 over 4. They're not giving you the lengths there in that fraction. So what I normally do is I will introduce a variable. Okay, just as a reminder, you might not even have to write down that variable there. I'm using y's now because I've already put x's over here. Okay, you can't use the same variable in different triangles. All right, so I'm just introducing that. I might not even have to write it as 1y and 4y. If I'm using this, I can just write 1 over 4, but that's just a reminder that those aren't the actual lengths. All right, they're also telling us that DE is 3x minus 1. Okay, so now I'm actually going to take away that x there, because now they're telling us actually this is 3x minus 1. Now, what does that mean? We know, according to midpoint theorem, if this is 3x minus 1, this length is going to have to be double that one. So 2 times 3x minus 1, which you can also write as 6x minus 2 straight away, if you want to. All right, whatever this length is, we said earlier, the third side of the triangle has to be double that length. All right, so we've actually already used that. And they're also telling us that GH is x plus 1. Oopsie, x. Oh, my pencil is not working. Let's see, x plus 1. There we go. All right, so I have that length in terms of x. I have that length in terms of x. I have that length. And they're saying, let me see, I put that in. Calculate, giving reasons, the value of x. All right, so I need to solve for x here. Now, guys, like I said, exactly what I said earlier is now coming true. We are going to have to use prop theorem in this triangle. Guys, this is a 6-mark question. Sorry, that's not on the screen. This is a 6-mark question. That means that you can give yourself 6 minutes to work on this. All right? That's a big question. That's a lot of marks, guys. And if you know everything here, if you're able to fill it in, it's actually not that bad, because what does prop theorem say? If you have a line that is parallel to a side of a triangle, like we have here, FG is parallel to CH, a side of the triangle, then this line, FG, divides the other two sides, BH and BC, in the same proportion. They've given us a proportion here, 1 over 4. That means that GH over BG is also going to be equal to that same proportion because of prop theorem. All right, so now I've made the same mistake again, and I've actually not put my stuff on this picture. But what I'm going to do now is I'm just going to take a screenshot of this, and I'm going to put it onto the other, there we go, onto the next page, so that we can look at it as we are writing our answer down. Let's see if I can do that there. There we go. Unfortunately, you can't do that in your exam. But that's why I said, guys, please, whatever annotations you make, do them on the answer booklet. What can also happen, right, is as a marker, when we see, oh no, this person left this answer blank, we actually look at your picture, guys. We see, oh wait, this person filled in 6x minus 2. I can actually give them a mark there. So please make sure that you do fill things in on the picture. All right, we often award marks on the diagram, even when you haven't written anything in the answer booklet. All right, so now we're going to say, where did the 6x minus 2 come from? Remember, from midpoint theorem. So first things first, we need to write BG is equal to 6x minus 2, and the reason for that is also midpoint theorem. You are allowed to abbreviate it like this. Is the answer 12, or are you saying what the grade is? All right, so BG is 6x minus 2. That is because of midpoint theorem. And now we're going to say, like I said, because of prop theorem, if FC over BF is 1 over 4, because of prop theorem here, x plus 1 GH over 6x minus 2 BG is also going to be 1 over 4. All right, so I'm going to write that down. X plus 1 over 6x minus 2 is equal to 1 over 4. The reason for this is prop theorem. And guys, super important, when you are using prop theorem, you have to state the lines that are parallel. So GF or FG is parallel to CH. If those parallel lines are not there, you are not going to get that mark, guys. That is very, very important. Please remember that. Okay, that is actually what they give the mark for stating the lines that are parallel. Okay, now this is an equation that will allow me to solve for x. I am recording the live. Yes, I have a YouTube channel. It's Miss Hanekom. I checked the other day. I have 560 something videos on there. So if you're looking for something, you can probably find it there. All right, I need to solve for x. I have an equation with fractions here. I'm going to multiply this side by 6x minus 2. And I'm going to multiply the other side by 4. So I'm going to end up with this. Oh, sorry. My hand went a bit shaky there. 4 times x plus 1 is equal to 1 times 6x minus 2. Now I'm going to multiply the 4 into the bracket here. So 4x plus 4 is equal to 6x minus 2. I'm going to move the 4x over to this side and the minus 2 over to that side. I'm going to have 6 equal to 2x. So that means that when I divide 6 by 2, x is going to be equal to, sorry, I'm not sure what's up with this pencil. X is going to be equal to 3. I can't remember now if this is in centimeters. They never actually said what the unit of measurement is. So I'm just going to say x is equal to 3 units. Oh dear, I don't know what's going on with this pencil now. Right, sorry about that. It's not fully picking up when I'm writing. Okay, that is that question, 6 marks. I actually quickly want to see what they gave marks for. All right, so you got a mark for that and then a mark for stating midpoint theorem. Then a mark for having this, actually 2 marks for that. So for that statement and having it in terms of x, and a mark for this reason. And then a mark for the answer, x equals 3. All right, maths lit. Unfortunately, I have only ever taught maths lit up until grade 10. So I am not able to write a maths lit cheat sheet. But you can ask Miss Angler. Maybe she has something in the works with a different teacher. So Bianca, I don't think they will take off a mark if you don't write units. It's just a good habit to do that. Yeah, so I think if you remember, put down units. Like, yes, I will put this on my YouTube channel. The 2023 June one, sure, I can look at some of those. I'm not going to do that today, but I definitely can in the future. Or I can do some questions on the other topics as well. Yes, we are doing another question. All right, next question. I'm actually not going to go through the proof because it's going to take very long. Guys, there is always a proof. All right, very important. You have to know. They usually ask a circle theorem proof. So please make sure that you know those proofs super well. You can see 5 marks here. Don't know if that's on the screen. 5 marks for that proof. The other proofs that they often ask are either the similarity proof or the prop theorem proof. So the circle proof is very important, then the similarity one, and then prop theorem. All right, we are going to look at the next one, 9.2. Physics? No, I don't teach physics. I did physics at school, but I don't think I should be teaching something that I'm not qualified to teach. All right, let's quickly read through this. This is a 9-mark question. Let's see if we can finish this by 5 o'clock, which is when I'm going to have to go, unfortunately. But then on Friday, I know I said we were going to be doing functions, but I really think we should get to this on Friday, which is the really difficult, last question on the paper stuff. So I'll do this either on Friday, or maybe I'll do separate videos that I'll post to my account here, where I do 10.1 and then 10.2 and then 10.3. I can actually do that tomorrow for you guys. So keep an eye on my TikTok. I will post these ones separately. All right, let's look at 9.2. They are saying in the diagram, which proofs they ask? The circle ones, and then they sometimes ask the similarity proof and sometimes the prop theorem one. Also guys, all of those proofs are on my TikTok as well. If you just scroll down a little bit, I posted all the fully written out proofs. There was just one mistake in the tan chord theorem proof, but someone commented that. So if you can just find the comment that I just wrote an angle's name incorrectly, everything else is fine. All right, let me just take a sip of my coffee quickly. All right. In the diagram, E, B, F, S, and P, E, B, F, S, and P are points on the circle centered at O. GB is a tangent to the circle. There we go. There is the tangent. All right, so I'm going to highlight that so long. Tangent. FE is produced. FE, produced, we've just spoken about that. Produced means extended to meet the tangent at G. OT, that line over there, is drawn such that T is the midpoint of EF. So T is the midpoint of EF. Guys, that is important, right? We don't often work with the line from center to chord theorems, but I'm hoping that you remember that when you have a line from the center going to the midpoint of a chord, now EF is a chord, right? And T is the midpoint of EF. So OT goes from the center to the midpoint of that chord, then that line is actually perpendicular to the chord. So I'm going to fill that in straight away before I even read further. All right, I'm going to remember that that is a 90-degree angle, and then on the other side it's also 90 degrees. But guys, I remember last year there were lots of complaints about this diagram specifically. It's so kind of squished, right? There wasn't really a lot of space. I mean, let me just try and draw a proper box there. There wasn't a lot of space to actually put information on this diagram. So I'm going to make a teeny tiny little block there, just as a reminder that both of those angles there are 90 degrees. What also happened last year, I remember I marked this question last year. A lot of people got confused and they put that as a 90-degree angle, or that one there, right? Just, I think, because it was so squished. A lot of people also put this in as 90 degrees. But that line over there, guys, is not going from the center of the circle, right? So you must be careful with these, okay? Yes, I know I must. Thank you, Bianca. I'm going to take a screenshot again like I did the previous time. But thank you for reminding me. All right, where was I now? Midpoint, okay. GO and BO are drawn. GO, all right, and BO, that's fine. BS is drawn through T. BS is drawn through T. They're saying that, guys, to tell us that this is a straight line. All right, that is the purpose of that little sentence there. And then they're telling us PS is parallel to GF. Very important, guys. Like I said before, they don't give you parallel lines if you are not supposed to use them. All right, so now I'm going to go through my whole Dr. Cape Town thing again. I'm going to write it up here. Okay, D is for diameter. They have not given us a diameter on this picture anywhere, so I'm not able to fill in a 90-degree angle there anyway. R is for radii. All right, we do have a radius here, which I'm going to just put a little line on, but now I actually have to put two lines on there, right? Because they've already used one line there. And then here, if we draw a little point there, that is also a radius. Guys, usually we only have to use the radius thing if we have a triangle drawn in there. Okay, so we're probably not going to have to use this, but it is good to just check. All right, the next thing, the C is for cyclic quad. We don't actually have a cyclic quad in this diagram. So firstly, they didn't tell us that we have one, but also, guys, they don't have to tell you. Okay, you can be expected to look at the picture and see whether you have a quad, so a shape with four sides, where all four of the points, the vertices, are on the circumference, so on the edge of the circle. All right, they don't have to tell you that it's a cyclic quad. They usually do, but they don't have to. In this case, we don't have one of those either, so we can tick that off. P is for parallel lines. Very important. We do have parallel lines here. I'm actually going to highlight these. So I'm going to draw in a green line and then another green line, just as a reminder that those are parallel. Let's see, can I make some green notes on here? Now, guys, we need to also be careful here because, again, of this cramped vibe happening here with point T. But if we look at this, do we see that angle there? Angle FTS and then angle PST. Do we notice that Z shape there, guys? Because these two lines are parallel, and this is now also why it's important to actually highlight them in the same color, because if you are just looking at kind of that that layout there, imagine these lines weren't highlighted and I'm not seeing that arrow over there, I might forget that this is parallel to this. Okay, so really it's a good idea to invest in some highlighters or even colored pencils before you go into your exam. FTS is equal to PST. Is there anything else that would be equal? Well, if I go here, if I look for an F shape, right, if we drew in that line there, that is an F shape there. This angle BTE will also be equal to PST, right? And also because of vertically opposite angles, those two angles would be equal, all right? So that is good. I don't think there's anything else that we can say at this point in time. Any other angles will be equal because of these parallel lines, but we've already filled in some values there. All right, so we're done with the P, I think. And then T is tangents. So let's see. They told us that GB is a tangent. Now guys, here, it's actually not, is it going to help us? Let's see. Remember that tan chord theorem? I'm just checking to see if we can use tan chord theorem. Tan chord theorem says that the angle between a tangent and a chord, so the only one that I have there is chord BO, which is actually a radius, right? Which is actually not a chord. So actually tan chord theorem can't work here. Do I have a radius to that tangent? I do. OB is a radius. GB is a tangent. So here we have that is going to be 90 degrees. All right, someone is saying corresponding angles. Yes, so that is BTG, that angle there, and PST. Sorry, did I not mention that they are corresponding angles? The F shape, those form corresponding angles. All right, so we have a 90-degree angle over there. Now, guys, also just be careful here. This is another thing that a lot of people got wrong. If I zoom in way close, this 90-degree angle does not go to this line. Okay, because that line, if I just zoom out, that line TB is not a radius. Okay, so it's very important. A lot of people messed that up last year as well. This diagram really was not drawn well. There's not enough space here. OB is perpendicular to BG. I'm actually going to write that on the side so that we don't forget, so that we don't get confused. All right. Someone is asking, when do I go live usually? I just kind of wing it. It's the first time that I'm going live now in ages because, oops, I finally have a phone that will allow me to. I'm going to go live again on Friday. I'm teaching until 3. I do an extra lesson with my 11s on a Friday, so I can go live at like 3:15 maybe would be the earliest, I think. 3:15 until 5. We can do an hour and 45 minutes. All right, I'm quickly going to paste this on top here. So for those of you that joined late, I was saying earlier that when you are doing this, when you are filling the values in, please make sure that you fill these values in on your answer sheet. So this book that they're going to hand out, you're going to get a question paper, you're going to get an answer sheet, fill in all your values on the answer sheet because then it's right there when you're writing your answer down. But also you could get marks for what's written on the diagram and not on the picture, or not written down in the box. Okay, so that is important. All right, what is the first question? I don't even know what they're asking us here. Let's see. Prove giving reasons that OTBG is a cyclic quad. OTBG. I'm looking the wrong way around. Oh dear. OTBG. Okay. So on here now, I'm going to highlight this in a different color. Let's do pink. So I have OT and then BG so that I know exactly what I'm looking at. Now guys, at the moment, in the way that it's drawn here, I do not have a circle going through those 4 points, but it could still be a cyclic quad. And if it is a cyclic quad, what that means is that we actually can draw a circle going through those 4 points. All right, ma'am, can you also say that the lines that intersect at T are vertically opposite? So here, those two angles are vertically opposite, yes. So the green ones that I filled in. So you could either say that GTB is equal to PST because of corresponding angles, or you could say These two are equal because of alternate angles and then because of vertically opposite. Yes, absolutely. That is correct. Okay, now guys, they want us to prove that this is a cyclic quad. Now, there are a few different ways in which we could do that. The first way would be, I'm going to write it here, to show that one pair of opposite angles add up to 180. All right, now if we are looking at this picture, if we're looking at everything that we filled in, we have basically filled in everything that we could see, right? So let's quickly take a look there. I don't have G, I don't have the size of that angle. I have a 90-degree angle there, but guys, this is now what people got confused with last year. This 90-degree angle is not the angle in the quad. The angle in the quad is that whole angle there, which includes that small part there as well. Right, so I don't actually even have a 90-degree angle. A lot of people last year wrote that this angle is 90, and then somehow they got that this angle is also 90, so they said that they add up to 180. That's actually wrong, okay? That angle that is 90 is not an angle in this quad. Okay, so this is not going to work this time. Then we could try and prove that the exterior angle is equal to the opposite interior angle. Let's see, do we have an exterior angle of this quad? We do actually have, no, we don't. I was going to say that this is an exterior angle, but that's wrong. An exterior angle is only if we had like that side, for example, was lengthened, right? Then the outside angle there would be an exterior angle. Okay, so we don't actually have an exterior angle here, so that's not going to work. The third way of proving that a quad is cyclic is if you show that you can do converse angles, sorry, my throat is a bit sore, converse angles in same segment. Now what that means is that you take, in your quad that they've given you, you identify one of the four sides, and which side is going to depend on what information you have. So I want to direct your guys' attention to GO. If we are looking at GO, right, if there was a circle drawn through these 4 points, GO would be a chord, right? Because G would be on the circumference and O would be on the circumference. So this would be a chord. And if all 4 of these points, like I said, are on the circumference, let me actually erase this and see if I can quickly draw in a circle so that you guys can see. I just want to move this. Oh, let me not do that. Sorry, let me quickly take that away. Oh dear. Okay, that's not going to work. Okay, never mind. Let me quickly see if I can draw a circle through these points. It's going to have to be a big circle. Let's see. If I just try, oh dear. If I try and make it a bit bigger, move it maybe. Sorry, I'm concentrating, which is why I'm not speaking. I'll be with you guys just now. Let me just try and get the circle right. That's not like 100% there, but I think that's the best we're going to get. Right, so can we see there? That one is just off, but I think you guys get what I'm trying to show you. Yes, this work is taught in grade 11, but it's tested all through grade 12 as well. So guys, what they're basically asking us to prove is that you can draw a circle going through these points. All right, now we can see on this diagram that we can, but if this is a circle, we can clearly see that GO is a chord, right? Because point T would also be on the circumference, because it's one of the vertices of the quad they're asking us to prove, do we see the angle that's being subtended there by this chord? It's a 90-degree angle. And then this chord is also subtending an angle at point B, another 90-degree angle. So that means that because we have a chord, right, GO, subtending, well, a line, I suppose, subtending the same angle at 2 of those points that they've given us, that means that there has to be a circle there, because the only way that that would happen, the only way that you would have a line subtending the same angle at 2 points is if that line firstly is a chord and if those 2 points lie on the circumference of a circle. So that is the third way of proving that you have a cyclic quad. You need to show that one of the sides of the quad that they've asked you to prove subtends the same angle at two of those points that they've also asked you to prove. So O, T, B, and G were points. So we're looking at GO. GO is subtending a 90-degree angle at T and also a 90-degree angle at B. So that means that this is in fact a cyclic quad. We need to write down why these two are 90 degrees though, hey, because those weren't given. We wrote that down. So I'm going to say, firstly, this is OTE, that angle, is equal to 90 degrees. So let me write that down. Angle OTE equals 90. The reason for that is line from center to midpoint of chord. That's the first statement. We also have to say why this angle at B is a 90-degree angle. So this is now OBG is 90. The reason for that is tangent perpendicular to radius. So OBG that is equal to 90. The reason is tan perpendicular radius. All right, and now we can say that therefore OTE is equal to OBG. Therefore OTBG is a cyclic quad. And the reason for that is converse angles in same segment. Very important that you have the word converse there, guys. If you just write angles in same segment, you're not going to get the mark. All right, the converse there is saying that you are proving that because you have angles that are equal, they have to be in the same segment of a circle, so therefore it is a cyclic quad. All right, so please, 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 that is one of the reasons that we are super strict on when we mark at the end of the year, is that you have the word converse when you are proving that it is a cyclic quad. Right, unfortunately, I don't have time to do the last question now. Let me quickly show you just what these marks were given for. It's 5 marks. Let me quickly get to the memo here, just so you can get an idea. Okay, it was 1 mark for saying 90, 1 mark for the reason, 1 mark for saying this 90, 1 mark for this reason, and then a mark for this final reason, converse angles in same segment. Guys, I remember from last year, we gave you 2 marks if we could see this on the picture and that on the picture, even if you didn't write this down in the block. So like I've said before, very, very important that you put that on your picture. All right, thank you so much, guys. I'm so glad that there were so many of you here. Thank you for all the follows. I really hope that this was useful. Like I said, I'm going to... Yeah, Hector, I have loads of videos on Euclidean geometry. You're just going to have to find them, but I do have playlists on my YouTube. Yeah, I really hope that this was useful, guys. All the best. I will see you on Friday. And if you can't join on Friday, please follow my YouTube. I will post the screen recording. I don't know if you guys can see that little red dot there at the top. This whole session has been recorded. You are welcome, guys. So IEB schools also do this work. Yes, absolutely. On Friday, we are going to be doing some functions. Guys, I do just want to punt my cheat sheet really quickly. Thank you so much to those of you that have bought it already. I worked super, super hard on writing it, and it is basically to help you get ready for your exams. So yeah, I would love feedback. If you have any suggestions that you want to make on that, then just let me know. Yes, not 1:15, 3:15. Gemini, thank you. Thank you, Lizzie. I am so happy to hear that you guys like the cheat sheet. Would you guys prefer to do Euclidean on Friday? More of that, or should we do functions? Quickly send some messages. Let's see. Euclidean or functions. I actually think what I'm going to do is I'm going to put a poll on my Instagram, so go follow me on there. I'm also working really hard to post on my Instagram almost daily. Very okay, most people are saying functions. Okay, but I am going to put a poll on my Instagram later tonight, so please go vote on there. Make your voice heard. Thank you so much, guys. I will see you on Friday. All the best. Bye.